those things you just sleep all day. I'm sure some of you've had days like that where you just did it anyway when you're on holiday or whatever. But unfortunately, my body just, I get up to go to work and I eat my breakfast. I fall asleep eating breakfast, and my wife just kind of nudges me and says, "All right, looks like you're not going in today." So I go and set up. I wake up enough to post something on Facebook and go back to bed, and she'll wake me up about 1:45, 2 o'clock to pray, eat lunch. Then I fall back asleep again until, about 5:30 or so, and then she wakes me up again. And then usually just before Margaret, she wakes me up and keeps me up until after Isha. Then I go to bed about 9 o'clock. So that's the way my days go when I stay home. It's not unpleasant. I'm not in pain. There's no stomach aches. There's no headaches. It's just I just sleep the whole day. And I have good dreams. Some not so good dreams. Most of them are good dreams. I'm on a beach with the grandkids. We're doing something fun that they're. Okay, let me talk a little bit about what the quiz is going to look like. And probably a good one is right there. Example right here is, I'm trying to find the example here. The example I'm looking at, like right there, is this one right here. And not this one here. This is, all right, this application right here. In other words, I will give you a problem that looks something like this. Matter of fact, this is probably a good one to look at. That's there. A person invests $1,000 into a savings account at 5%, assuming the money is left in the account there. So it earns I was checking some other stuff earlier today. So if you assume that you're going to, as a matter of fact, this is probably just a good place to slideshow, start from the first side. Right there. We've already talked about the for statement right there. But this is a formula right here. And we'll see if, you see that the magic pen doesn't work today. It worked last time, right? Now I've changed nothing. I'm plugged in the same HDMI cable, same computer, same that there, and now it doesn't work. So the mystery of all times, why this pen doesn't work. That there. All right, regardless, you have this amount that there, and what it simply says is that right there, notebook. Since my pen doesn't work, I'll have to go to OneNote. Is that if I take $1,000 ringgits right there, we'll assume it's ringgits, but I'm going to use the dollar symbol just simply because it's shorter right there. You put $1,000 ringgits into a bank, and it pays 5% simple interest, compounded yearly. It means at the end of 1 year, you're going to have 1,005 right there, right? You leave that 1,000 sitting there. So you're going to have, say, 1,012, and I'm just guessing at the number right there, the next year. Because I'm not going to give 1,010 because I earned 5% on this extra five ringgits. It's probably not going to be 2, but so we'll say it's out there. But it compounds. The interest compounds. And the formula for that, right there, is a relatively simple. It says that A equals the principal times 1 plus R, and R is the interest rate, so that's 0.05, raised to the number of years. So A is the amount at the end of the year, right there. So that is the formula. And what this particular one there is, they're wanting you to create a table with 1 to 10 years of how much this $1,000 is going to be at the end of each of every 10 years. That there now, 5% is I think that's what I think EPF paid about 5.6% this year. Tabahaji paid about 6%, something like that. So that's not an unusual rate. If you invested in the stock market, I don't know how the Malaysian stock market does, because I have very little money that there, but U.S. stock market pays about 12% per year. That there over the course of the stock market, but some years you lose money, some years you make money. That's a problem with putting money in shares. It's not a fixed interest that you get every year. So when you do investments, you've got two types of investments. One is the type with risk, and when I say with risk, that's not the same as gambling. That there, it's haram to gamble, and even if it's not haram to gamble, it's stupid to gamble. That there, but when you invest money in Maybank, see, I buy Maybank shares in Maybank. Sometimes Maybank makes money, and I get a dividend, and the shares go up. Sometimes Maybank doesn't make so much money, so I don't get a dividend, and the shares go down. So investing in Maybank is, a risky venture. I've had money in the U.S. stock market, and back in about 2000 and trying to think, when was it? About 2008, 2009, the stock market crashed big time, lost about 50% of its value. At that time, I had probably 150,000 U.S. dollars sitting in the account, and all of a sudden became worth 75,000. That there, I lost a whole bunch of money, but I didn't lose any money because I didn't take any money out. My ex-wife had some money in, she took it all out because she was afraid she was going to lose everything. And now that money is grown, and it's now, now it's up in the 400,000 and 500,000 range. I mean, it's gone the other way. So, but I'm a big fan of investing money young and early because it grows. And if you look at this particular problem right there, this is the solution for it. I suggest you look at it between now and next Tuesday, because I like these kinds of problems. It won't be this problem. It might be a more complicated version of this problem right there, where I do annual deposits or something like that there. But right there. And what this basically says is that by 1,000 ringgits becomes, and I said 5, it's actually, it went up to 50. I did my math wrong that there. But it goes from 1,000 ringgits in date at year 0 when I put the money in, and at the end of 10 years, it's now worth 1,628 ringgits, right there. So you can see what happens when you let money grow with compound interest, that it's actually quite a beautiful thing in terms of if you were to run this table through and put in 10,000 ringgits when you're 20 years old and see what it is when you're 55, you would see that you can become quite wealthy, that there. I started saving when I was 25, and there. So, but this is the problem. This is the type of problem. So what you would see me do at the beginning of class next Tuesday is I would give you a problem like this, and then I would probably show you this. That there. As a matter of fact, I may just put them both on Facebook just as class is getting ready to start. Right there. So, again, It's open book, it's open laptop, it's open thumb drive, it's open. I mean, we don't. Well, yeah, there is a book on the on the homepage or VLE. It's open everything but your friend, and no texting on your phone to ask questions either. It's not open phone. You can't use your phone out there for text. Out there, I don't know how I'm probably gonna have to walk around in the room, look to make sure you're not Facebook messaging each other during the exam. I mean, when you let students do computer exams, there's so many ways that people can cheat today, right? I'm sorry to say is that you've got Facebook messaging, you've got textbook, people hiding their phones, they're texting each other. You've got all kinds of things. But again, what I'll do is I will give you those two pieces of information, and then you're going to be given an hour or two, probably just give you whatever time. And when you're done with it, and you can get to the solution, you go ahead and just post it on the VLE along with a screenshot that it's working. It's going to be pretty much a binary. I'm still going to get in trouble with the Dr. Tyrell in terms of grades goes, but I'm getting close to retirement anyway. They can fire me if they want to because my grades are too high. I don't care. You can tell them I said that I'm getting close to that retirement age anyway. And most people, we used to call it in the Air Force short timers syndrome. When you're in the military in the U.S., you sign a 4-year contract with the military. And probably 90% of people back when I was in the military did a 4-year and out. In other words, you did your 4 years. At the end of the 4 years, you're eligible for GI benefits, which is GI is a government issue, but you're eligible for what they call veterans loans. You're eligible for free tuition at universities, which is why that's how I paid for my college. You're eligible for health care benefits at VA hospitals if you need to. So you do your 4 years and you get out. And as you get close to the end of the 4 years, people have what they call the short timers disease, that their term is almost up. Now, I actually got out and then I turned right around and went back in part-time But then you could do like my sister, and she got out and she was in the Marine Corps, and then Desert Storm came and they called her back in. You do run into that problem once in a while, that if there's a need, you're available to be reinstated back in the military at the military's wishes for so many years after you get out. And my sister thought she was done. She had a daughter. She was all happy in civilian life, and she gets that phone call saying, "Welcome back, Corporal Hack. You're back in the Marine Corps. That their report to such and such a base at such and such a date, and bring your old uniforms." That's it. Okay, but that's the test right there. So there's a couple of other examples here. The fourth statement, and again, my pen is. I have yet to figure out. One of these days. I've got another one of these, 2 more of these pens, and I want to see if it's the pen or I keep forgetting to bring the other pens. And it only happens when it's connected to projectors. There is a function here called power right there. That is used, and you'll probably have to use it for the assignment right there. So you pass it requires 2 double, but again, you have to define your variables as that there. Because if you look at the program, you'll notice that the power function is there, right here. It's being used. And again, it's funny because it shows the red dot as I move. You see the red dot? As soon as I draw the line, it draws the line in the wrong place. So that tells me that the pen is working at there. But as we're looking here, power here, rate and year are defined as doubles in order to do that. as a general rule, anytime you're doing math calculations on financial data, you should probably use double anyway because of the accuracy, and you don't want it to round off here, right there. So that's there. So, but this formula, right there. So again, this here, now this formula calculates the amount for a particular year. Now, if I say was to do something, where's my cable? Oh, there's my cable right here. I actually have already started thinking about the lab, so I'm gonna. Let you think about it a little bit here. Maybe. Yeah. Well, I'll put it, well, at there. This is actually one where you put in a deposit every month, for example, that there, and how much it would grow over the years. So that's what I most likely would probably put on there. This actually gives the formula, but you can look the formula up. I'll give it to you the day of the exam anyway. Okay. So the only thing that would change would be this formula, most likely. It would be very similar to this example right there. But the formula, but it may require that you calculate using months versus years, depending on how I get the problem. Right there. I may say that the interest is calculated monthly. I may say it's calculated yearly. You don't know how I'm going to tell you it's going to calculate it. But it's going to be a retirement account, savings account type problem right there. So, right, okay. Right there, they talk about the fact. Also notice that we also have included another library, math.h. So you'll have to keep that in mind as you're doing the quiz, that math.h has to be required if you're going to use the power function. Power is defined in math.h, the header for it. It's actually, again, contained in the library, but if you don't include the math.h, you'll get an error with the power function right there. So, okay, let me just continue on through there. So again, function prototype, that talks about that there. And again, this also talks about the fact that we're using double because of the fact that we're dealing with dollars. Again, you could be talking dollars, ringgits, it doesn't matter. It's still financial units, right? So, okay. Variable, float, or double is that there. They talk about error prevention. Do not use types float or double to perform monetary contributions. That's there. That there. Here we're talking about is that it has much greater, but it occupies more memory. Again, professional programmers generally prefer double to float right there. If you're using float or double, and you're doing any kind of if then else or if then doing comparisons, make sure you're using a greater than or equal sign or less than or equal to, because they are not precise values right there. Here they talk about that there. And examples, so it goes wrong, and I don't care about the $2 amount. One is 14.234. It's going to be printed out as 14.23. In other words, the 0.004 is lost. The 0.003 is lost on the second one. So you actually, if you're to do the addition without, you're going to get 32.1 that there if you do the addition, but the two of them that there. So sometimes you get results that don't necessarily make sense. It's kind of like when you look at a bank statement. You got a bunch of money scattered in different accounts. They add up all your accounts, and it comes up to 99.9% that there, or 100.001 percent, when they add up all the amounts, because these there's round off errors is all they're saying here. And what they're saying here is when you add 14.234 to 18.673, the answer is going to be 32.907. So if you print the answer, that's going to be 32.91. But when you print off the individuals, it's going to be 14.23 plus 18.67. You add those two up, and it comes up to be what? It's going to be right around 33, right? So so you're not going to get the exact answer. The answers that there. So your print-off would look like this. It would be printed. So what they're saying is this 0.1 is lost right there. So again, that just happens right there. Conversion factor 21 point right there. 21, this is used to format the output in order to take 21 spaces. So if you're going to print a table, that's why they do that, is for the table. So the 0.2 is the number of decimal points to the right. 21 is the width of the table. Because if you go back and you look at the printout right there, you notice that there's a big gap between these two. And that 21 is what caused that gap. Because you add up 0.345 6, 7, and then you've got a bunch of empty spaces there, 14 empty spaces on each of these right there. So that's what that 21, if you look at the code here, you see 0.04U, that means use up 4 spaces, and it's an unsigned integer, and then percent 21.2F, that means that it's a floating point number. It's got 2 decimal places to the right, and it takes up 21 spaces in the table right there. So again, you might want to look at this program before next Tuesday right there. And it might not hurt to have it sitting on a thumb drive or something. That there, because my guess is you probably make some changes to it and be done in 30 minutes. Up there. It's not going to be the same problem. I guarantee you that. It's not going to be, and it's probably going to be a more difficult problem. Up there. But if you understand this one and you understand the lab that I just gave you, you should be able to do it. That's the whole goal. That's it. Okay. All right, I'm just going through these here. Right there, again, they talk about the number can be less. This will automatically be right justified. In other words, it's placed to the right, to left justify. You put a minus sign, and I can't circle it, but I'll bring my mouse down here. So this means that we're going to left justify in the table right there. So in character strings, we can say that it's going to be 8 characters wide, and we want to left justify it. So we can either right justify or left justify. Normally people right justify. Right justify prints it off this way right here, where everything lines up on this side here. If I left justify, everything would be lined up here. Right there. So you can do it any way you want. It's just they tell you how to do it right there. Okay. Now, on to our next statement, and that is the switch statement. The switch is a multiple choice. It's like the if statement, only instead of having else's, we have choice 1, choice 2, choice 3, choice 4 right there. So it consists of a series of case labels with an optional default. Always put a default case in there, because if it's not one of the predefined cases, probably it's an error right there. And so here we're using a switch to count the number of grades earned on an exam right here. So here, what we're going to be basically doing is put string, enter the letter grades, enter the end of character. They're introducing a new concept here. It's called the end of character. It's Control Z on the keyboard. But EOF stands for end of file. That's a character that's defined within the computer programming ASCII set right there. And Control Z is how you emulate it on the keyboard. If you're reading a file and the end of file does a scanf, scanf is where you read a file, and you've reached the end of the file, it will return the end of file character. So that's why it's called end of file. So we enter one grade at a time and enter the EOF character as the end input. You could just as easily put in, enter minus, enter Z to end or whatever. But in this particular case, it's looking for the Control Z right there. So we're going to while grade is equal to get char, and we're using a new function right there. Again, I can't write my line there, but right there. Grade is equal to get char. That's a function call that gets one character from the keyboard right there. And while it's not equal to EOF right there. So I just keep typing letters in, so I can just type A, B, C, A, B, C, A, B, C. And I just keep typing these letters in as long as I want. When I'm done, I hit Control Z right there. So we're looking here is case A, uppercase, and case A, lowercase. So if it's either a upper or lowercase a, we're going to increment the A count. And then we're going to break. We're going to exit the switch. No sense looking at any of the other characters. We've already found the one we're looking for. So if it's not an A, we look to see if it's a B. If it's a B, we increment the B count. We hit the break. We break. C, we hit the, we increment that there. And the default, in this particular case, right here, here we have the F, that there. We ignore the new line, the tabs, and spaces. In other words, we list those three cases there, and the only thing we do is if we see a carriage return, a tab, or a space, is we just simply break out. We just ignore it right there. That's how we ignore it. Then our default, if it's not A, B, C, D, F, a space, a carriage return, or a tab, we're going to print incorrect grade entered and enter a new grade right there. And again, optional break right there. And we just keep doing that as long as the person enters grades right there. So what we've got here is this new concept here of using this switch that there, so we don't have to do if grade, if grade equal A or grade equal lower A than A plus plus. Else, if grade equal B or grade equals lowercase b. This actually saves a lot of typing because we know it's going to be A, B, C, D, F, or one of the other white spaces. We call those white spaces. Tabs, spaces, and carriage returns. That there. So this simply just keeps track that there. Right there. And then when we're all done, we just output a put string. Totals for each letter grades are. And then for A, again, we just have a unsigned integer. A count, B count, C count, D count, F count. And we're done. So it's a relatively straightforward program right there. And here is an example of what it would look like to run right there. So here we type A, B, C, well, uppercase C, uppercase A, lowercase d, F, C, E. Notice E is an incorrect letter grade, so we got an error message there. We don't increment anything. If you look back at my code here, when we have our default, there's no incrementing. We don't increment any of our valid grades right there. A, B, C, A count, B count, C count, D count, or F count. That's not incremented right there. So that's there. And then we hit the Control Z character, which is the end of file that there. And it just prints out the total right there. So it's a relatively simple program right there. Right there. To do that right there. So, but that's the switch statement, and it's very powerful for some tools, and I assume we got a couple of more examples in the slides right there. So, again, this goes through and it just simply explains the code from the beginning. The get char, of course, and you could use, instead of get char, you can do a scanf, but get char actually is a better call than if you're only reading one character. Because if you do the scanf, you have to hit the enter key. If you don't hit the enter key, you don't have to hit the enter key. In some compilers, ours you might right there. Returns it in the int. That's there. So there. Now they talk about the char value actually has an integer value that there. And they talk a little bit about the A has a value of 97. We don't need to worry too much about that. They talk a little bit more about that there. A grade equals get char, and it returns back into the char right there. So, but chars actually are 8-bit integers is what they are. It's stored as an integer is what it's stored as right there. Right there, and program grade is equal compared to the end of symbol right there. Again, that's the Control Z right there. Normally has a value of -1 as a sentinel value. So if I try to read a file and the file is at the end of the file marker, the function's going to return back -1, which is the end of file marker. So I could use -1 that there. So right there. And of course, if you're running on Mac or Unix, I didn't realize that Mac OS, yeah, of course I should have known that. Mac OS is a version of Unix. Most people aren't aware of that, but if you have a Macintosh, it actually is a version of Unix, the underlying operating system. So Control D is the control character and the file marker. On a Windows machine, it's Control Z right there. And you may have to press the enter key right there, and this simply just goes through right there. A break is not used anywhere. It's going to continue going through and looking at the other cases right there. Now, the problem is If you don't use the break, the default is always going to be executed. That's the problem that you need to be looking at here. Is these breaks here? You got a break here, a break here, a break here. If I don't put these breaks in, it's going to continue checking each one of these, and then when it gets to the default line, it's going to execute it every time. So you have to make sure you put the breaks at the end of each switch right there. Also note that you can put as many cases as you want, and then here's your code right here, right there. Also notice we don't have to put a parentheses, braces in this particular case right there. So I can put multiple lines of code in here without the braces. If I put the braces in, it doesn't hurt. Too many braces don't hurt, but the switch is one of those cases where you don't need to put the braces for a block of code. But make sure you do the indenting properly. Right there. So, right there. And this simply goes through the break, talks about the break, the default, the flow chart. It looks like this right here. And notice if you don't have the break, and again I can't write the line here, but if I don't have the break here, then it's going to drop over to here. This is going to come here. This break is what causes it to exit the case statement right there. So the break is needed right there. And again, we've got 3 cases listed. All the others had 2. You could have 15 cases listed if you wanted to. Right there. So often you must be specifically processed. This depends on the computer and the compiler. And I have no idea on Dev C whether you have to hit the A and the Enter key. Some compilers I can hit A, B, 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 C, 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 and it's going to keep track of all of them. Some I have to hit the Enter key. It just depends right there. And he is very clear in saying often this new line character must be specifically processed to make it. So in other words, even the author of the book says, I don't know if you need to hit the Enter key or not, right there. So again, you could put these together on the same line if you wanted to. Normally you list them separately like that there, which can only test a constant integral. You can't use less than or equal to or ranges. I really wish I could, but you can't. So if I wanted to look at numerical grades, I would have to get 100, 99, 90, all 10 grades. I can't say less than or equal to 100 and greater than 90. Yeah, that there. I can't list a range like I do on an if statement. I can only list the individual numbers. So if I wanted to use a case statement, determine whether or not a person gets an A, B, C, D based on the numerical score, I would have to have 100 lines right there. Although you could actually go 40 lines to 60, and then if you hit 59, then have it just default to an F, right? That there. But you would still require 40 lines. You'd have to list 100 to 60 individually. And again, I'm using the scale 0 to 59 is an F, 60 to 69 is a D. It's even more that there. So, but when you use the switch, remember that each can only test a constant integral expression. So it's only a character or an integer number that you can use right there. It can also use Boolean expressions too, and others that there. Characters must be enclosed in single quotes. If you put it in a single quote, it's recognized as a character and interpreted as a number, ASCII number. if you put in a double quote, it's interpreted as a string, and the case doesn't recognize that there. So, again, portable languages might have flexible there. I'm not going to go through this particular slide right there. Talking about long ints between very large numbers, short int, signed char, and then unsigned char. Typically, char is what we're going to use for any character right there. Okay, the next one is, and I'm going to end this chapter in this class with this discussion here, is the do while. The do while is exactly like the while, except for we put the while at the end of the loop. So the only thing that changes is that the body of the loop is ran at least one time. With the while right here, we have our condition, and here's our code right here. So we check this condition. If this condition is true, we execute this code, right? If this condition is false, then we skip this code. We don't execute this code. The do right there, and the while here, right here. Here's our condition right here. There's our body of code. We always execute the body of the code one time. Then we check to see if the condition is true. If the condition is true, we go back and we do it again. If it's false, we drop out right there. So the do while is exactly the same. That's why I'm not going to spend a lot of time on it. That there. But the only difference is that it tests the condition after the body of the loop is performed one time. The while does the test, and then it goes through the body of the loop, and then it goes back to the top, does the test again. If the test is false, it drops out of the loop and doesn't do it anymore. If it's true, it does the loop one more time. That there. So a do while terminates after the right there. So the while is the header, and here is the do while. It's a very similar statement. It's just a matter of whether you do the test at the beginning or at the end of the loop. And there's no reason to use the do while at there. So a do while with no braces around a single body appears is this, which can be confusing at there. So they're basically, what they're saying is you should put the braces in. If it's only one statement, you don't have to, but it's a good idea to put the braces in. But this is do and then print counter, while counter is less than 10, less than or equal to 10, and we increment the counter, and that's the do while. So the flow chart looks like this, right there. Now we can put breaks in our do whiles in our switch statements right there if we want to escape early. It's considered with do loops and for loops and while loops, putting a break statement in and exiting the body of the loop early is actually considered a bad programming technique, because normally you follow the single entry and the single exit rule right there. But there are times you have to, right there. So here, for example, this is a for loop, and we said that if x is equal to 10, in other words, if x is equal to 10, we're going to break out of this loop. what we're going to do. So this is going to just simply, if x is never equal to 10 or 5, then we don't break out. I think I said 10 a minute ago, but it looks for a 5. So this loop will only execute up till 5, and then this break will cause it to break out of that loop, even though we set it for 10. Again, why would you do this? Well, again, you might be looking for a control Z character or a control delete or some kind of control character to exit some loop in order to get out of it, that they're an escape code. Right there, so, and this just simply goes, and then you also have the continue statement, which actually is going to, right there, continue at there, skip the remaining code in that there. So basically what this does is, this word continue means don't break out of the loop, but skip the rest of the code. So when I run this code here, I say if x is equal to 5, I'm not going to say equal, but it's, that's implied in the if. If x is equal to 5, continue. So when I look at what's printed down here, notice that the 5 is not printed because it skipped this line right here. I personally don't use breaks and continues in 90% of my code. I almost never use them, other than the select case. I should make an exception with the select case that you have to use the breaks. But within for loops and while loops and do loops, it's actually considered a bad programming technique to use that there. So, the right way would be if x not equal to 5, print x at there and not have that continue in there. I mean, it would do the same thing. So I think that I forgot there is the other thing. I'm not going to dwell a great deal on it. I said I'm going to finish this chapter here. But we have the logical ands or ors and the nots. These are for our if else, our conditions, anything that's in a parentheses where I show a condition. I've been showing parentheses as a condition. So I can say if A less than or equal to 10 or B greater than 100, for example, right there. That's a condition right there. And this is an or. I can put an and. So I can make up to if sex equal F and not married, and we're going to assume that that's a Boolean expression, married, that's either true or false. So if that there, printf possible wife, right? That there, So I'm just, making right there. But again, but if you're a male looking for a wife, there's two conditions that have to be met, right? We could put more there: age greater than 12 and age less than 60 and things like that. I mean, I'm not suggesting marrying 12-year-olds or that there, but in my case, it's age greater than 45 or 50 out there. But a key thing here is what we're looking at here is that we have these logical, so that we can, in our if statements, we can get more complicated other than looking for one thing. We can look for multiple things. That's there. And I use the example of, the potential wife as, you might have a whole list of things that you may want to put in there. Sex equal to F, married not equal to married not equal to true, age greater than 20, age less than 30. Religion equals M for, Muslim. Weight under 100 kg. All kinds of things you might, and I'm picking on the guys, but you would list a whole list of criteria when you're looking for, and I'm sure the women have a similar list of criteria that they would have out there. I'm just, out there. But again, we can tie those all together. Same thing as looking at grades, that there. So we have that there. We also have the not that there, and I used that in my example a few minutes ago, right there, where I said not married. I put the exclamation mark in front of that. I'm assuming that married is either true or false, and we haven't declared Boolean variables yet. That'll probably be the beginning of the next chapter where we declare Boolean variables, but we're going to assume that there's a variable called bool, and that's married, and we could say it's either true or false right there. So if sex is equal to F, in other words, it's a female, and she's not married, then we can look deeper into the situation right there. So, right there. So again, here we're looking at if gender equal 1. So they're using gender as 1 as a female, and the age is greater than or equal to 65. It's a senior citizen female list. We have another old lady to add to our list right there. So that's there. So, and we're using the and symbol and to. If you use a single and, that's going to do a Boolean and function. We haven't talked about that there. So you have to use the and, ampersand, or the or, which is the capital, where is that on my keyboard here? I don't see it on my keyboard. I know it's on this keyboard. It's right above the enter key on my keyboard, right there. Your keyboard, this keyboard, yeah, it's right above it's right next to the enter key, above the right shift key on these keyboards. My keyboard's a little different because it's a toy keyboard right there. So again, this is looking for right there. Now, you can set up truth tables right there, and we can spend all of that time. I'm assuming that you've had a course in basic digital, have you not? Yeah, that there. If you've had a course in basic digital, you've gone through Boolean truth tables right there. If not, I'm not going to go through them here, right there. So you've got the logical or. So in this particular case, the professor, and I've done this in the past, I don't do it here because the rules here don't allow me to do it, but I used to have a general rule that if a student can get a 90 or better on the final exam, they get an A in the course, despite however they did throughout the semester. That's there, which is a great incentive for students to do well on the final exam, right? That's there. So they can completely sleep through the entire semester and ace the final exam, they get an A in the course. Which means that you write really hard at final exams, right there. But But this simply says if a student's average is greater than 90 or their final exam grade is greater than 90, they get an A in the course, right there. So I know UniKL's got a restriction that says that your final average must be greater than 40 and your final exam grade must be greater than 40 to pass the course, right? You have to pass the final exam in order to pass the course, right there. So again, that there, truth, that there. And the negation there, It says if grade is not equal to, again, they put this not here, right there. You could also put the not equal to right here. This says if grade is equal to set no value, if that comes back as true, then this is going to negate that and make it a false right there. And that's the same thing as you would normally see that in the not married example right there. So again, this just kind of goes through the order. Again, I'm not going to go through that slide. It's worth looking at. Oh, I just said that I would be at the beginning of the next chapter. It's actually in the end of this chapter. There's a standard type called bool, B-O-O-L, right there. And any non-zero value sets it to 1 right there. And you do have to have the standard bool header right there, shorthand right there. And bool, true and false are that there. So you have any variable that's declared as a type bool, I don't know how you would pronounce that. Yeah, I keep wanting to say bool as in bulk, that there, but Boolean algebra, it's so bool is probably the right that there. Can only take on 2 values, true and false, right there. There. So that there. Visual C doesn't implement the underscore that there. And again, for example, that there. Now, not all compilers have that built in. Sometimes we have to define it right there. That's done at the beginning. I was right, it's the beginning of chapter 5, they talk about that there. I've already talked about this before. Equal, and equal are 2 different things. If you use within a condition the single equal sign, what it does is it does an assignment, and then it says, is this 0 or not 0, the result of the assignment, and it's almost always going to come back as true, right there. Because the problem is this does not show up as a runtime error. It shows up as a logic error, which means that the program runs, it compiles, it doesn't crash, but it gives you bool results, and I'm going to spell bool, B-U-L-L this time. The results are garbage right there. So runtime logic errors, right there, 2 aspects right there. So it goes through, and this just explains what happens. But here, if pay code is equal to 4, you get a bonus. The second time, if pay code is equal to 4, we've made pay code equal to 4, and we give them a bonus no matter what pay code was. The second case will actually assign a 4 in the pay code and give a bonus because it's non-zero. So if you write this particular code in a payroll program, you've given every employee in the company a bonus. Right there. You're a nice person. You gave everybody a bonus in the company, but the chief financial officer and the CEO of the company are probably not going to be happy with the increase in payroll. Right there. So, I used to work for a company many, many years ago, and when I was in management, which was the absolute worst job I had in my life up to that point, probably still is the worst job I ever had. We used to get monthly bonuses depending on what the company did, but I was the shift foreman for a brake shoe company, made brake shoes and clutch facings. It was a pretty dirty, nasty factory. It was a really rotten job there. And it was probably, like I said, one of the worst jobs I had, because middle level management is always a bad place to be. But I used to get a bonus, and then I left that job and I went to work in the quality control lab, which was not a management job. It was a salaried job, a flat monthly salary. It paid actually a little bit more, but didn't get a bonus there. But a couple months they accidentally gave me a bonus check. Unfortunately, I had to give them back that there, but that was a case where my pay code got messed up in the database. So, but again, the key thing in this example here is that the first one here where we have the equal 4, that does a comparison with pay code to 4. And when we compare pay code to 4 and it comes up false, we don't get a bonus. The second case, we make pay code equal to 4, and if the result of that is true, which is anything positive, other than -1, it's going to give every employee a bonus right there. Because any non-zero is true, but the actually receive a bonus regardless. So everybody gets a bonus in this particular case, right there. So again, this is going on to some other things right there. When we're doing standalone statements, you want to normally do assignments. You don't want to say x = 1 as an assignment, but actually what that's going to do is either going to evaluate as true or false and do nothing with it, right there. I think that's the end of our chapter right there. Okay. You said, can't tell. Is he finished? No. Sometimes, you can't you can hear, you guys probably hear better, you're closer to the door than I am here. But okay. These are just, the kind of the flow charts that they're, one of the things he does mention is that you should have a single entry point and a single exit point of each statement right there. So that kind of violates the rule of using the continues and the breaks right there, other than you notice that we have the breaks here in the switch statement, but as a general rule that there you have a single entry, single exit right there. So again, this is just showing the whole idea that we don't exit midstream on most of these up there. But there, and repeatedly to the flow that there, this doesn't really. The nesting rule tends to look at this idea is that here, what we're looking at here is that we've got an if condition here, and then we've got two if else's right here, right there. But I don't worry about flow charts that much up there. But we're going to get into building blocks at there where you don't there. See, we have stacked building blocks; those are sequential. But when we have an if, then there, if we have a for loop, it's got to be completely within the if statement. If we have an if within an if, this has got to be completely in. We can have multiple statements here. We can nest these. We're going to see nested loops. We're going to see nested for loops out there. But we don't overlap our loops right there. They can't be overlapped right there. And I think that this is just going through the structured programming again right there. And I think that I'm going to wrap this chapter up at this point right there. So, okay, tomorrow I'm going to start the next chapter. I'm not going to go very far. I'm going to answer any questions. Remember, Tuesday next week, I'm basically just going to sit up here and do nothing. I'm going to give you an assignment. I think I'll just put it on Facebook before the class starts. That way I can use because I'll probably put it up, but it'll be just before the class starts. So if you're late to class, I'll know that you went and looked up the answers. So that there. But it's going to be, the only reason I'm going to do it on Facebook is that way I don't have to leave the projector on the whole time. That's the only reason I would do it on Facebook right there. But you'll see what the assignment is. I'll explain. That's there. And I'm not going to put it up 2 hours before class. That gives you a chance to go look up the answers and try to do that there. If I had a way of switching this room off from the internet other than the Facebook page, I would, but I don't have that there. But it's a straightforward problem. It's not, it's not going to, my guess, anybody who's did the homework and looks at the first example I gave you should probably have no trouble with it. But obviously, I'm put in a situation where I had everyone turn in homework last semester. I had no way of showing that each person did their own homework, and I got scolded by the committee saying that you gave everybody in the class an A and you don't know if anybody did the work there. So that's why I'm forced to do it in class now. There. So with that said, I'll go ahead and start chapter 5.